Hi, I'm Gary Wagner, General Manager of Ophir Spiricon here in the U.S. We measure lasers. Here at Photonics West 2014, we're featuring high-power measurement devices. Right behind me here are our power meters and sensors for 1,000 watts and above. This unit measures up to 30,000 watts. At this show, we are introducing over here our 100K power meter that we've just recently launched and have tested at the Japanese laser research lab. So why are we featuring high power? Well, as you know, the high power YAG and fiber lasers are really taking off with manufacturers introducing them into industrial parts manufacturing. You see them everywhere, from 1,000 watts all the way up to 30,000 watts in commercially available applications today. In fact, we're working with a company which is reducing the cost of deep well oil drilling by lowering a fiber down into the well with a 50,000 watt laser behind it to fracture the rock, thus breaking it up and not causing the drill head to break. Here at the show, we're introducing a 100 kilowatt power meter. That's the largest power meter ever produced commercially. A few years ago, I actually saw one produced by NIST, the American Institute of Standards, for a military application, and it was about twice this size and weighed 350 pounds. This one's only about 130 pounds. The way this operates is on the calorimetric principle. You put water in, you take water out. If you know the temperature of the water going in, you know the temperature of the water coming out and the flow rate, a simple physics equation can give you the total overall power that's being put into it for the measurement of the laser. Another product that we're featuring is beam profiling, and that's looking at the spatial distribution of the power across the face of the beam. You can see behind me here the software displaying what would come out of this camera. The beam is hitting the sensor itself, and the image from the camera interpreting it into the profile. The profile here, as you can see, all the powers in the center are like a pencil shape, and that's really used for cutting. If you wanted to weld something, you really want the power to be flat across the top. If you'd use this kind of a shape for welding, you'd end up poking a hole or burning a hole in the weld. So what we're featuring here is a completely new way of measuring high powers. No longer do we have to put the beam on the surface of a camera sensor. We actually have developed a device here where the beam goes directly through without touching it. There's a hole right there. So this is Beam Watch. It's designed specifically for very high-powered lasers from 1 kilowatt up. And we've just currently, with the power meter, the 100 kW power meter that I just previously showed you, in conjunction with it, we were measuring the profile of the beam and the power of the beam. So what we want to measure here, the profile being where is the focus spot, assuming this is my laser, it connects down to a focus spot. We want to measure the divergence of that beam into the focus spot, and we want to measure if that spot moves in the first many seconds after you turn the laser on. If that happens, we can measure it and characterize that beam so that the user can make modifications to their process to control all those variables, thus making a good weld or cut each and every time. Here displayed on the screen is the software that's interpreting the focus spot size. We actually are measuring the Rayleigh scatter, and that's basically what makes our sky blue. The energy is hitting oxygen molecules. The molecules are putting off various wavelengths, and our eye actually can see blue better than any other color, and that's why we interpret the sky as blue. We use that same principle here. The high power laser is going directly through. We have a camera that's looking at that Rayleigh scatter and displaying it on the screen here. And you can see dynamically that as the laser is turned on, the first few seconds, the red line is where the focus spot was when it starts, and it's actually migrating down several millimeters away from the original focus spot that we want to understand and control in the process. Thanks for joining us here at Photonics West. I want to remind you that one of the advantages that Ophir Spiricon can offer is that our extensive set of sales engineers can come to your site and measure your laser under your conditions to provide you the best solution to your needs. Please visit us on the web at ophirop.com.